Hello and welcome to this video on graphing sine and cosine with period changes and phase shifts. The first example that we're going to look at is g of x equals -3 cosine of x over 3. So you want to identify the period, the amplitude, midline, and phase shift before you start, so that way you can plot your x and y axis appropriately and go ahead and get a good graph, a good looking graph. So the first thing that generally people do is you would want to identify your amplitude, which is your A value. Here you have an A value that is -3. So your amplitude is the absolute value of that. So that's 3. It's also important too to note that with a negative value, you're going to have x-axis reflection, right off the bat. So I know those things. Next, your k value, which is usually added on at the end back here. This is your k value. Your k value is 0, so your midline will be y equals 0. Now, the new things that we're going to add in are period and phase shift. In this example, I'm only going to adjust the period. Now, you should notice that 1 over b is your multiplier with your x, and in this case, your 1 over b value is 1/3. So the period is 2 pi divided by 1 over 3, which happens to be 2 pi multiplied with 3, right? When you're dividing by a fraction, you multiply by the reciprocal of the denominator. So here, in this case, your period is going to be 6 pi. Now, the only other value that we didn't see, again, it would be represented with a minus and then a value, is our c value, minus c. That would be added on in here. We don't have a c value, so we don't have any phase shift at all. No phase shift. Okay, so what we'll do is we'll go ahead, we'll plot a x and a y-axis, and I'll put my y-axis here, and an x-axis right down the middle. And we'll go ahead, now we'll label this, so I'll just go up, say this is 1, 2, and 3, -1, -2, -3. Okay, and now I want to be able to fit my graph in here. So period is 6 pi, so I'll just say that this would be, what, I don't know, pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi. So I should be able to fit at least one cycle in, and then I can also go the negative direction as well. Okay, so I'm going to go ahead and I'm going to graph my function. Remember that this is a cosine function. So cosine starts at a maximum, or in this case, since we have a negative a value, it will be a minimum. So I'm going to plot my first point, which is here at -3. And I have the end of my cycle is going to be here at 6 pi. Okay, and oh, sorry, I almost forgot too. The midline generally is a good thing to plot right away. So there is my midline. Okay, so I want to plot my other significant points. Remember that with these functions, you want to split it into fourths. Okay, so if I was to cut 6 pi in half, that would be 3 pi. Okay, so I'm going to have a critical point here at 3 pi, and if I was to split each half in half, so 3 pi, and I'll divide that by 2, that's here, so that's 1.5 pi. Okay, there's a critical point, and then again another 1.5 pi, right? So this distance is 3 pi, cut that in half. This distance is 3 pi, cut that in half. So here are where my critical points are. So cosine is going to be minimum. I'm going to have an intercept here at my midline, and then I'll have a maximum, an intercept, and then another minimum. So this is what the graph should look like. Okay, and going in the other direction, I have, so every about 1 pi and a half, I have a point. So 1 pi and a half, and then I'm going to have a maximum here at 3 pi. Okay, with a y value of 3. So there is our graph. G of x equals negative 3 cosine x over 3. Okay, here is the second example. In this example, now we don't have an amplitude. Notice how the amplitude, your a value is just 1, so your amplitude is going to be positive 1. So I'm not really vertically stretching or compressing. However, we do have a k value, which is negative 3. So we're going to move down 3 units for our midline. And then next, I want you to notice that the 1 over b value is equal to 2. So what we're going to do, we're going to take our period, 2 pi, and we're going to divide by the 1 over b value. So I divide by 2, which gives us a period of pi. So in this case, with this graph, you might want to expand out your graph. So what you're going to do, we'll make an x-axis. Since we're going to shift down, I'll put my x-axis up rather higher, and then I have my y-axis. I mean, I can put it down the middle there. Okay, so let's say this is negative 1, negative 2, negative 3, 4, and 5. And I know you guys don't like to label, but it's super important, especially with this, since we are shifting around, to label your units. Okay, and what I'm also going to do here, what I should have done in the last video, is I'm going to plot my midline right away. So at negative 3. So this is kind of the central line of your function, right? It should be symmetrical relative to this line. And the last thing I need to do is I need to determine my scale. Since our period's pi, right? So maybe every unit will be a pi fourth. So 1, 2, 3, 4. I'll just say this is pi. So that's going to be 1 period. So pi, 2 pi, and I can go this direction. 1, 2, 3, 4. This is negative pi. 2, 4. This is negative 2 pi. So with this, I should be able to fit 4 periods in. Okay, and phase shift. So the last thing I just notice, again, you don't have a c value. If you have a c value, it'll be in parentheses. It'll look like this. So again, that'll be the next set of examples. We'll have phase shift in here. But let's go ahead and let's plot this graph. So no phase shift. We have a sine of theta function. Sine of theta starts at the origin. So and my period is pi. So every pi I should be back at this point. And what I'm going to do is I'm going to split it in half and then into fourths. So here, here, and here I should have a point. So every one of these units I should have a critical value. Okay, the amplitude is 1, so I'm going to go up 1, and there will be a point. Then I'm going to go back down, minimum, intercept, maximum, intercept, minimum, intercept. If I go over here, maximum, and I can continue this direction. So minimum, intercept, maximum, intercept, minimum, intercept, maximum, intercept, and minimum. Okay, and we get, that's not what I wanted. we get our graph. Oh, that's terrible. That's still terrible, but okay, so there we go. Okay, and so this would be one period, right? Boop, that's pi. And again, and I'll just finish it off. So there you are. There is sine of 2x minus 3. Again, it featured a midline shifted down to 3, and we had a period which is horizontally compressed. Normally, this would be one period, right? But we fit two periods in one. So really this value here, you got to think about opposite. When you see 2x, maybe you're thinking, you're going to stretch it by a factor of 2. Remember, it's the opposite for horizontal. Horizontal values are always flipped. Okay, so those are two examples on affected period, and after this practice problem here that I have for you, I would like you to do. We'll look at phase shift. So at this point, please pause the video. Try this on your own. Identify your period, your amplitude, midline, phase shift. Hint, hint, there's going to be no phase shift in this example. So graph it, then come back and check your work, okay? So hopefully you pause this video. Please check your work. Hopefully your graph should look like this. You have a midline of 2, an amplitude of 1.5, and with a 1 over b value of 1/2, you get a period of 4 pi. So every pi you should have a critical value. Maximum, intercept, minimum, intercept, maximum. Okay, so please watch the next video. Next video we will talk about phase shifts.